implemented, what are its components, what are the nuances around it. Naturally, these are the things which can go very long in terms of covering all specific item, but from the cohort's perspective, the executive level and decision makers perspective, who are owning programs, initiating new projects, I guess we can cover decent ground in this session, right? So that's the way we are. Now, to take this session forward, we have also included our tech team here, the team which has been instrumental in architecting and implementing solutions. So we have Sumit here. I'm just going to switch on my video. Sumit, you can switch on. So we have Sumit with us. Sumit is AI architect, and he has been implementing several solutions, predictive model, agents. So he's having vast experience of several years. I guess more than 5-6 years, Sumit, if I'm correct, building
Yes,
all these
yes,
solutions. Yeah.
yes.
Then we also have Chandan with us. Chandan is our member developing AI solutions. And actually, he is one of the person working closely with Sumit on several different projects. So we have Chandan. So now the idea here is to involve the team which is being instrumental in writing code, so that we not only look at the design aspect, the motivation aspect, we also really get inside those code level aspect. If all of you are really interested in that, that would be great. Now, the way this session has been structured, we have put this into basically, you can put this into 3 sections, right? So one section, the first section, what is going to be is a section which will talk about how exactly AI agent comes into play. What is it that makes the difference, and why it is so much popular these days, why people are really going after learning, implementing, adopting it in their workflow. So we'll talk about that briefly. We will also talk about what are the different mechanism, the kind of workflow we talk about in our daily life, how the complexity of an AI agent varies from the lower spectrum of, you can call it relatively simple implementation, rather the simple agent, and then naturally progressively moving toward the right of the spectrum, where we talk about lot more complex agentic systems which are able to have some kind of a decision making, some kind of a arbitration when we talk about workflow. So that's the kind of discussion which we will have. We will talk about what are the different components which makes a agent, and all those components are all key. We have talked about it in some sessions, regular sessions, but we will go in bit more detail here. This is what is going to be comprised of in the first section. It should last 25 to 30 minutes, I guess, and we can always extend it based on as question come. Now, the second section is going to get inside more design aspect of an agent. And very soon you will discover that the agent, implementing agent, there are two aspects. One aspect is looking the workflow and then figuring out how this workflow can be divided for my own task. And this other aspect is how to implement that, the technique part of it, right? So these are the two things. And I can tell you, by the time we end this session, you would have realized that implementing an agentic system is more of an art than a science. Maybe it is difficult for me to explain right away, but I guess by the time we end, you will realize that. And that is something which we have to keep in mind, that it is going to require a creative thinking when we talk about design. So the section 2 is going to talk about the design aspect of an agent, and that's where Sumit will spend a lot of time in explaining why these considerations are in place for designing an AI system. In the same section 2, Sumit also is going to, he has put together a quick agent which is going to fall in the category of medium to high complexity. but at least it will give a fair bit of idea about how a agent is implemented. He will take you through the code, how different parts of an agent, the component of agents are implemented, what are the different code semantics, and then you guys can always have questions around that. So this is what is going to be in the section 2. In the section 3, we will have some of those agents which possibly can be quite interesting to look at in terms of how the implementation are done and then how shape it takes. You can have some kind of a demo of it. Naturally, that's something which we did not talk too much into the sessions, but we will talk about that now. And in the same last section 3, we will also leave last 15 minutes for any kind of a Q&A. I guess this is what 2 hours will be good to get a good insight into what a agentic system is. And I'm very sure you would be able to take several takeaways, several learning from this so that we can straight away get into action. So without losing any further time, I'm just going to hand over to Sumit from here and we will keep it on as and when we are required. Any of you have any question, you can raise your hand or you can drop on the chat bot and then we will address that question immediately, right? So that's the kind of flow what we will have. Like usual sessions, we will have a break of 10 minutes in between and at the right time we will set this out. So right now I guess we have got several people right now. Maybe more should be joining, but then let's see. So over to you, Sumit. You can continue now from here.
Thank you, Vinit. Thank you so much for the welcome and that setting up the context for this entire session. This session primarily, as Vinit talked about, is more on the implementation side of the agent, but certainly we will be setting up some context in order to reach out to that point where we will be able to understand the problem, their complexity, their components, all those areas, and then gradually we will move towards the implementation of the same. So from design to how a bit of deployment or maybe a bit of UI element we will also covering so that as entire system you can have a perspective of an agent system how you can build, right? Okay, moving to next. Just 1 second. Yeah. So first, we need to understand why we are using agent, right? There are key things which we need to understand. First is nowadays we see traditionally earlier you have the chatbots, LLMs. Now around 2022 it released that LLM part of it, right? And then we started to have some query out of it, and then that LLM or chatbots were giving some response, right? But nowadays, what is happening is those LLMs are becoming and transforming into agent part of it, where it is being integrated to different systems, like you have database management, you can integrate chatbot, you can integrate your LLM or agent with those systems, right? So that is the trend which we are currently seeing, where where initially that LLMs was the part of what we called as a monolithic system, where you just put one part of the query and it generates the another part of the query. But now it is more on the compound side of the system, where you have that certain elements of your systems like database or any other external APIs, so that those system can be integrated with the LLM, and hence it tends to become and behave like an agent. Second thing is nowadays this automation alone is not no longer sufficient, because there must need some intelligence out of those AI agent, right? Simple rule-based automation will allow you to do a certain aspects of the task in automation, but when you have the intelligence being uh, enabled for those automation, the entire system become intelligence, because that time you receive data from different sources. It could be some internal documents from where you could get some data, and hence your system would become more intelligent than what it usually tends to. So that is what we see also, that agent could help us to provide that intelligence out
Hello.
within that automation pipeline.
Yeah, hi.
Yeah, hello.
I saw your message.
Yeah, I see some noise in the background. Anyone asking question or is there noise? I'm not sure.
Yeah, will do.
Okay. I think people
So
can put on mute. That's better.
that's where we come to see that within the industry or the enterprises that it's just not that the normal automation which are going to help us. There's certainly some intelligence which is particularly related to the specific use case, or it could be any internal policy related thing or anything which could give your normal automation and intelligence part of it, right? And out of that intelligence and the automation, you can derive some action, you can derive some alerts out of reports, some to the different stakeholders or the process owners, right? So that's where enterprises are getting more evolved in terms of intelligence, where they are making their AI being embedded with different kind of external system or the internal system, and that's where they're making their entire agent as an intelligent agentic system. Yeah, so we will be focusing more on the implementation side of it, just to give why we need agent, just to make sure that because in the real time, what you see is that in the real time, you have certain aspect of the data, right? Suppose if I have to give you an intuition, right? So you have, suppose I am going for a vacation. Now, if I have a normal LLM, right? Like ChatGPT, if you go to that consumer platform of ChatGPT, you write, okay, I'm going for vacation. How many days are I can take leave, or how many days are left for me. The leaves are on the disposal from the system, right? So we don't know how that LLM doesn't know that your database or how many leaves are left with you to make sure that vacation can be of 7 days, right? Now, if you integrate that LLM with your internal database, that's where it gets to know, okay, this user has this number of leaves left, and then kind of it can help you to solve that your query, right? Whatever you have asked him or what goal you have set asked LLM to derive that solution, right? Going next, how we can see that these AI agents are impactful. To understand the impact of agent, we need to understand the change, right? So anywhere, if you see the changes in the transformation in the business, that's where the agents are becoming more impactful, because they are driving those changes in a manner where the decisions could take a more in a better way. The ownership of different uh, processes are now there as a centralized location, and when you have the ownership, and then you tends to make some decisions, right? So that's where the change is there, where agents are now becoming more and more informative. Imagine you have a different sort of data scattered around different systems. So maybe it could be some legacy system, it could be some data coming from S4. Now, all those data sources has to come up with the one view, right? If you have certain process that is going on within your organization or within industry, you tends to see that data is scattered in a different manner, and a person working on some process is very hard for them to keep track of that one view of the data. So there are a lot of dependency there. So their AI agents are making help in giving a kind of ownership, because it is giving you the one view of all the data sources which are used for particular tasks or to achieve a particular goals in a view. In one view, if you have that sort of information available to us, so suddenly the decision making becomes more enhanced. And once your decision making are getting enhanced, certainly the action you can derive out of it is more impactful, right? So this is the change what AI agents are bringing into this change, right? And how these changes are being coming into picture, right? You have certain systems, just like mentioned, if you put your database with your LLM, now it can tell you, okay, you have these many of days left, right? So this kind of more system you can being integrate with your LLMs to make it more agentic, right? So AI agent basically means you have more faculty of information coming out of different sources, and that's help you to make decision more grounding, and ultimately it will help you to make some action, or maybe some alert has to be sent out, or uh, some reporting has to be done. So those kind of action can be taken care of using AI agent. Yeah, so it second is operate autonomously with rules and intelligence. So there is a trade-off that generally in industry we used to make how much autonomous we want our system to be there. Suppose you just want to get the number of days out of your leave, right? So you can just have one single database, and every time if you ask how many days are left or what are the uh, other things related to that particular database data which you have in integrated with the LLM, right? So if you ask something else apart from this, suppose this is your very basic agent, right? You ask something else, okay, how you have told me that this number of days are left. Now, if I ask the next query, can you please tell me uh, how, how much sunscreen I can take up with me so that I can be safe from the sun where I'm going to take that vacation, right? So then it will definitely will get failed. Why it will get failed? Because it doesn't have that information. It doesn't know the weather condition of that place. It doesn't know uh, uh, that how many numbers of sunshine hours will be there in that location, right? So it tends to fail there, right? So this is where you decide the autonomy of that particular agent. If you want very simple use case, just want one rule to follow, you can have that low level of autonomy. If you want more autonomous, you can divide that particular tasks into subtasks, and those subtasks can be handled with different some more agents you can put it into to handle those tasks. So instead of you manually giving some input, they can handle those things and then they can come up with some more intelligence, right? But the process will become a little slower, right? Because you are increasing the autonomy of that agent. So in hence you are taking more time to giving time to resolve those queries, right? Which you in generally, if you just write one simple queries, so it will take more time to process because it will then create subtask of it. Those subtasks can be handled with different agents, and then they come up with that solution. They provide information to one decider agent. It will decide and give you some kind of output report, right? So that trade-off you can always make when you are going to decide, okay, this kind of solution we need to build, this kind of goal we need to achieve, that autonomies you need to decide, right? Certainly, third point, your AI agents can interact with tools and system, which I just talked about. One of that, it can interact with your database, it can interact with your external data sources like coming, there are some news that are coming from system which you require to feed into your agent, right? Those news feed can be fetched from the external system. So like that, it can interact with different tools and system using system design principles that technically people who build those system, they knows that kind of things. Right. And the four and the most important point why AI agent what change it does and how it is impactful is definitely it improve efficiency in repetitive tasks, right? So for example, there's some repetitive tasks in your day-to-day life or in your work profile or in your organization, right? Every day you have to do that task. It could be reading some particular email coming from particular source, and you may have to do every day same thing. Then those tasks you can definitely use agent, right? So that your manual fatigue can be reduced, your manual effort can be reduced. And in hence, when you reduce those manual defense, definitely the efficiency, you will get more time to do certain things which you are not doing as of now. Suppose I want to take some, suppose there's some meeting every day, the project meeting that is going on from me, and then I want to keep a follow up with those meetings. What are the being said in those meetings? So there could be some meeting of minutes being created, and then it has to be passed to the different stakeholders. Then there kind of some kind of it is a repetitive task, right? Because every day you have to create a meeting of minutes, and then you have to send those meeting of minutes to different stakeholders. It's a very manual effort and time consuming task. There you can use some agent which can extract the transcript of your meetings, and then use some prompting to create the structured meeting of minutes, so that your efficiency can be improved, right? And when you increase the efficiency, certainly the error in making those nodes are reduced, right? Because now those agents are much more informative and much more uh, reliable than what we may have overlooked some key points which they generally don't do, right? So we may skip some key important elements, but definitely agents help us to recall all those as important element and hence reduce those errors, right, which human generally tends to make. Coming to the next point, so far I think I am able to give a little idea about uh, how AI agents actually making change in the organization and how those changes are driving the business decisions, right? And definitely, when we go forward, we will be more able to grasp all those things and link the dots together. Yeah, just to conclude, what exactly is the AI agent, right? So AI agent typically means that system which can reasons, right? This is a very important point, reason. Why, how it is reason, right? Suppose I just give that's again same example if you talk about, right? That LLM which just have the database being integrated to that. So every time if I ask other than any leave query, it is going to fail. Why it is going to fail? Because it is not able to reason there exactly. It is able to reason for one thing, which is, okay, I have the database as an environment to me. I can I can just take something out of it. Now assume I have also integrated the weather condition. I am taking weather data from some external sources, and apart from my internal database, I've also added my weather forecast data or maybe weather some other data source. Now my model, my agent has two things to reason, right? One is whether I have to use my weather thing or whether I have to use. Now it can reason now because you have given, you are increasing the environment to that agent, right? So once you have that environment, once you give more and more context to that agent, it become more intelligent. That's where we call it tends to reason out of different environment or different situations or uh, different context system that you have given in order to solve your query, in order to accomplish a task, right? So that's where it tends to reason because you have certain number of uh, environment being given to your agent, right? Second, uses LLM models for understanding. So LLM is a base foundation layer for any AI agent, right? So AI agent, if you talk about AI agent, is that it internally uses LLM, right? The foundation model, but LLM itself is not sufficient to make it solve every kind of query, right? So you have to integrate different kind of tools, right? Those tools are doing some particular tasks, right? In case of previous example, right, if I add weather data, so it is like acting like a task, right? It tends to calculate, fetch that weather data and then try to tell you, okay, this is the weather condition, 4 hours or 5 hours sunshine hours are currently in this month, and you can take these things with you while going to vacation, right? So LLM is the basic foundation layer, and once you enable your LLM to do certain amount of tasks, right, certain amount of things to perform, that's where that becomes an agent, right? Doing something, acting something is called agent, right? So how it acts through tools, it acts through different data sources. So if you provide different data sources, it tends to accumulate those sources of data. It tends to correlate that data, and based on the query, it is going to respond to you, right? So once your LLM are interacting with tools and data, it became an AI agent, right? Last points is AI agent. Definitely for any AI, not just the AI agent, any AI, it has to have some goal, right? It has to work towards some goal, right? So, but the goal first, you define a goal, then you have that planning layer, then you have you are planning for, if you are planner divide into subtask, then you can use multi-agent, and then you execute that task, and then you get an action done. So this is how that entire AI agent workflow works, right? From defining the goal to the action, right? There are certain layers which works within that entire framework of the AI agent design. And I will be covering those aspects definitely going forward. But this is on the high level how you define an entire life cycle of AI agent, starting from setting up the goal, then you plan your goal, how to achieve that goal, then you have the memory so that you can retrieve the context, then you have execution layer, right? And after executing, it will give you some response, it will give you some alerts, and based on those alert or response, you can take an action. Suppose, for example, if I have to do a crop prediction, right? In crop prediction, what I want to maximize the yields for farmers, right? What I can do is I can define, okay, this is my goal. I want to maximize the profit. I want to maximize the production yields of that agriculture particular item, food commodity, right? Now, next thing, once I have that goal, I could have a planning layer where I can enable some tools which can take data from sensors, which can take data from uh, again weather, because crop dependent on the weather conditions, soil conditions. So all those data can be integrated with our LLM so that it knows the environment, it knows what kind of query I'm solving and what kind of information I need in order to plan that entire thing. So once the planning stage happens and the entire you get the soil data, you get the climate data, then you have the memory layer, which could have the previous experiences of the agent, which could be that this month you have that yield. So it tends to have that memory layer, and then executor will execute and tell you, okay, now this much you can do irrigation so that your yields can maximize, right? That execution layer. And definitely once it, suppose sometimes you get the wrong response or wrong results, you can always observe and then feedback so that it learns and then again uh, give you the proper solution for your goal, right? Now let's talk about so far any question before I hope I'm able to convey my idea of
Yeah,
AI agent, right?
yeah. We can just wait 30 seconds in case any question pops up, Sumit. Okay. Yeah, I think Lakshmi Narayan ji is having one question. Yes, sir, you can go ahead.
Haji, I have understood till now. My only question is, what exactly is this agent?
So agent particular is a task, right? So when you define something to do, you want to achieve something, right? You want to do some particular task, right? In case of, suppose I want to give a disaster, suppose disaster management is something, disaster management response, something what we are working on, right? And there is some earthquake happen, right? Now, if you ask your LLM, just a normal platform, you go to ChatGPT consumer platform, if you ask what should I give that, how I can tackle this situation of disaster management, there is some earthquake going on, right? It won't give you the right result because it doesn't know where that earthquake has happened, how much damage has been done. It doesn't have that satellite data. It doesn't have that image data of collapsed building. All those things are not available to our consumer platform, right? Now, how you are going to even that solve that problem? Now you have to make sure that you get the data, how you are get, what kind of data you may have, the images of collapsed building in that area and those being sent out to you. Now you can use Vision AI model, which can detect that, okay, this is the area where that damage has happened. Now that is a kind of rule, right? Where you are taking some information. That is a kind of tool. That is a kind of task that you are trying to do. Now that data is coming. That is a task which is being handled by your large language model, right? LLM. So once the LLM is performing any task, any external task or internal task other than just giving you the response, which takes like information from different sources, that's where it becomes an agent, right? I hope
Just
that
to add
answer.
to, yeah, just to add to this, what happens is you can visualize agent like one of your assistant, as if your task, what you do, in a certain situation where you might be doing certain task mechanically without having any additional intelligence needed for it, and you simply do it. Or there can be a task which requires one to think. That means you have one of your companion, one of your assistant, think of it like an assistant who is acting on your behalf because you have programmed it to do that particular work. I think at this stage, if we can limit this definition to level of uh, doing a companion work, doing a assistant work, I think that would suffice, because as we go along, we'll get more and more clarity how and what needs to be done. But in short, this is how we can imagine it to be.
Oh,
Yes,
okay.
Sri.
I understand. I understand. Okay. Fine. Thank you.
Okay, coming to the agent complexity, how in general we decide what kind of agent it is, how, because complexity is very important to understand what kind of problem I am solving. So based on, depending about the nature of the problem, you define that complexity in your agent, right? If it is a very single task, if there is only one or few tasks that is going on, you could have low complexity, right? You don't have to take care of much of the task, right? It's a single task. It could be just reading an email, right? It's a single task that is you have to do. Then you can use a simple low complexity agent where you can use one agent. You can bring some kind of tool to solve your problem, and that tool will work, and agent will wrap that response from the tool, and it becomes a very low complex agent, right? Then medium complexity, when you have more and more tools being used, more and more resources are coming. Resources like you may have different data coming from different sources. It could be some legacy system, it could be some SharePoint Excel file, it could be some SOPs, standard or SLA agreements, internal, it could be anything internal documents which you want to process simultaneously. You want that all the sources to be in a one view, and you want your agent to understand all those sources in on behalf of you and take some and decide and do some uh, reasoning and come up with some output which we have already uh, prompted it to do. So what prompted we have prompted it to do, it will come up with some those kind of decisions, and then based on decisions, those certain actions can be taken, right? So that's where medium complexity comes into picture, where you are not doing just handling one thing, you are handling different sources, you could handle different other system, maybe the database, uh, maybe some external API. So as you increase the number of tasks with your agent, that's agent complexity is getting increases. Now, third is your high complexity. What does high complexity means? High complexity is like you are interacting with multiple agents. It's just not having one agent with multiple tools or one agent doing one task. Now multiple agents are interacting with each other so that they can come up with some strategic reasoning, right? Suppose I have to do two or three tasks, right? I can have three agents with enabled, and then those three agents can do their tasks, and then they can come up with their information. They can supply those information to one agent, and then one agent will decide, okay, what decision has to be taken care. So as you have that number of agents being increased, from one to two to three, the complexity is getting increases because you are now doing more, more and more work, right? And in this scale, we can think of like low complexity is a very fast system, and high complexity is a very slow response system, right? Why it will be slow response? Because in low complexity, suppose in the case I was just asking, okay, just give me the number of days out of the data. So it's very low complexity, right? Now in high, it will, whatever you write, if you write anything else, even though it will give you the same kind of results because it doesn't have any other environment or any other source being given to make your query solvable, right? But as soon as you start to increase the complexity in order to solve that query or in order to accomplish a goal, you may have to increase number of tools. So once you increase the number of tools, it will take some time to process, right? Uh, so the time of process, number of tools or number of agent as it is increasing, your time to solve that problem is also increasing, and hence your accuracy is also increasing. The autonomy is also increasing, right? Earlier in the low complex, you may have to provide some input so that next time it could not give you that kind of results. But if you are making very high complex system, you are using multiple agents. So maybe earlier that particular agent task you are doing it manually. Now you have added that agent to do that task. Now that task is not anymore a manual. So that's where if you keep on increasing the complexity, the reason, the power of reason of those agent enhance, because now it can collaborate with different agents. It can get the results. It can use different tools in order to solve your problems, right? So this is where actually agent problems lies into these three categories, and we as a developer, we work on a trade-off between how much autonomy we want in our system, in our agent, right? So that's where this complexity, understanding this complexity is very important. Let's see with the help of example, how does what does I mean by low complexity? Just to in order to give you also an intuition and the different how you can look into your day-to-day life or your in organizational processes or different business scenarios, and try to figure out how I can identify to start with low complexity agents, right? So if you have some single repetitive tasks, just like creating meeting of minute, or just have some particular single which every day you have to do, you can use low complexity agent because you have only one task to do. You don't require multiple agents, you don't require multiple tools, right? So that's where you could use low complexity. It just have some clear rules in the form of prompt or instruction, and the control is more on the low complexity, right? The autonomy is less. So it's very important to understand when you are building any low complex agent, you may have to uh, you may have to lose some autonomy out of it, because it won't give you uh, other information which you have not integrated so far, right? So if you have only doing one task, it's become low complex. And the third point, no independent decision making. So it has to rely on human intervention also, so that if it is not giving you the exact result, you can always improvise and make sure that your agent is working fine, right? Let's look into the low complexity example, simple email parsing agent. And this is one of the example which is pretty much I see, even I have worked on this use case in one of my client, right? Where I've been given a task to initially when this LLM entire thing came up late 2022, we are being given, okay, let's try to read this different emails from the customer, right? Now, this simple email passing agent, why we are considering this as low complexity? Because you can use one single agent, you can use limited tool, and deterministic outcomes means you are trying to have a fixed outcome, right? You want to either convert into a particular spreadsheet. Just every time if you are having some incoming emails, you are extracting some key information and you are storing into some data spreadsheet, right? So here we don't require any other tools or anything to read that email, right? So that's where very limited tools or any external tool are being used, right? Just that LLM is reading and storing that information into an spreadsheet. The place where I have implemented this thing, where I had the use case is credit and collection team in the finance operations. So there they used to resolve the customer queries for the different product and services that clients serves to those customer. Now, what was happening for credit and collection that time? It was like they were receiving a number of queries, and So what they have to do is they have to manually read all those emails coming from the customer back and forth, and then they have to identify whether this customer is saying this is a dispute of invoice or it is a payment promise. So they tends to give some data like what is the status of my invoice? This is the invoice number. Can you check whether this the payment has been done or not? So there was some certain scenarios that we have to extract out of that email, certain out data that I have to extract out of that email. Now, once I extracted that data like invoice number, amount, and I identify with the intent by reading the email, right, that this customer is saying he hasn't received any invoices. So it's like he's trying to say this is a dispute. So that time collector has to manually log that dispute in their S4 system or system where the ticketing can be done. There was that entire scattered workflow because there were a lot of dependency. There was data that they have to integrate with that customer invoices or response. They have to look for different sources. Okay, look, let's go to that resources, pull this information for this invoice. Let pull that from different resources. They were pulling that information for that particular invoices, and then they were drafting an output manually and then logging into it manually. Now the entire process is being automated. Now LLM reads that information, LLM extract invoice number, amount, company code, another customer number, other details. Then it went into different now different system where that invoice information are available. Then we do some weak lookup and all those things, get the relevant data, and then create an output in the expression. So this is how a very general low complexity agent you can start to build with your emails and where you have very and less number of tools being used and your outcome is deterministic. Now, let's come to medium complexity agent. As we have shown in the previous slide, you have three scenarios: low, medium, and high. So when when we transition to low to medium, we tends to we realize that as soon as that number of integration, number of complexity, how complexity can be defined, right? Because we need to understand first if there are different information or different sources which can give you information to your LLM and help you to resolve that problem. So why not to add those things, right? If I have certain data available to me and that data can help us to resolve any of my query, why not I can use that data, right? So that's where complexity increase, right? If you keep on increasing, maybe you could have data from CRM, ERP, or any other legacy system, any SharePoint drive, OneDrive, anywhere it could be saved, right? And you want that information to use, right? All those information you want to use. So then you can, that the complexity is getting increased because then you have to add all those data to your LLM. So that's where the complexity is increasing, right? Now you can, as you know, that complexity is getting increases. Suppose you have to build dashboards, right? Your LLM are giving you some response, it is giving you some insights, and out of that insights, you have to build some dashboards. That is also one of the thing you are integrating with your agent, right? So again, complexity increases, right? Because you have more connection, you have connection with different sources, you have connection with dashboard. Suppose I also want to do some forecast, right? I have some data where I want to predict some kind of risk, maybe in compliance. If any changes in external policies, changing my internal policies can impact my internal policies. I want to check how much risk I am into. Suppose there's some news come up on labor policy, and then I have to compliance with my internal labor policy of the company. So that's where you can do some forecasting also. So forecasting is also one kind of tool you can enable your LLM with. And once it do the forecasting, it can wrap that forecasting result. LLM can interpret those results in a better manner, represent into better manner. But again, you are adding that forecasting into your LLM, that's into your agent. That means you are adding the complexity of it. So as the number of information point, as the number of tools you are keep on adding to your agent, it becomes complex and it tends to behave more autonomous than your low complexity agent. The third is conditional decision logic. Certainly, you have certain tools which are giving you the information, and the agent has to decide which tool I have to run based on the query. Suppose I gave a query related to some CRM and ERP data, then it must not run that forecast tool because that is not needed. So that's where you have to prompt it the conditional logic, which tools to be run, for what purpose, for what kind of query you can run those tools. And definitely the last is every time you have to make an orchestration of all those tools and workflow of the entire system. So orchestration is always important while developing so that you can keep track of uh, the workflow which you have built it and it is working as you have imagined or as you have developed so far. So this is all about medium complexity agent. I talked about if you are having n number of data integration sources, then the complexity increasing because you have to make sure your that data is available to your agent. Second, you want to create the dashboard. Certainly, you have to integrate that dashboard and you have to act on the output of your agent and supply that output to a dashboard so that that is also again increasing that complexity. By dashboard, sometimes business uses that dashboard to get some insights out of that entire process which are happening for them. Right. Now, third thing is predictive modeling. As I talked, if you again, I want to do some kind of forecasting, I can create one machine learning model, maybe simple model, regression model. I can build. I can do a risk prediction or any kind of prediction on the use case which I am working on, right? For example, the fraud case detection. So I can build it in fraud case detection. I can build some predictive model where it can predict, okay, this particular transaction for this customer is going to be is suspected. I suspected this transaction. So that alert can be raised, right? So again, you are adding that predictive model to your agent. That means you are increasing the complexity. Alerting system again, it's like after you know that this is the final response, this is the final action, you can always attach the alerting system. And this is very important. This alerting system, we generally tends to think a very late part of our projects, or sometimes we generally involve more into the other areas, but we tends to forget this alerting system in the places. And it is very important, right? Because because the stakeholders doesn't know what exactly you are doing, so but they must know how the process is behaving, right? So that's where you can enable that alerting system based on the outcome from the agent. You can send out the alerts to different stakeholders. You can send emails to process owner of those particular process. So this is how this entire medium complexity agent can be defined. As soon as you get more uh, uh, integration of different things, your complexity is increasing. Again, last, so this is more we have written in the below. You can also go through it with multiple system. It is connected with multiple system. It is connected with performing analytics, and it is also triggering downstream actions. So that's where the medium complexity comes into picture. A high complexity agent. Think of an system which is having multiple agents, and those multiple agents are working towards achieving one common goal, right? That is where this high complexity comes. And for high complexity agent, there is more autonomy rather than medium or low, right? Because now you are using different agents. In if I have to talk about one of the use cases, like if I have to work on compliance and regulatory intelligence system, right? I can use one agent which can talk with my internal content store. Internal content store, which I mean to say is like you have some internal data source where your internal documents are kept. Your agent can always read those documents, right? This is my one agent. Second agent I can build, okay, I also have some news feed or macro changes in the economy which is happening, or maybe some change in the uh, labor policy, all those sort of macro changes happening around the globe, or external to your system, or external to your organization, external to your process. I can build one agent which can deal with all those external changes, right? Now one more agent I can do which can coordinate all these two, right? So now I have three agent kind of system, right? You can see how I'm increasing the complexity. One, my main agent is just taking care of, okay, what kind of query it is, and based on the query, it is trying to get the information from one agent using the internal data source, and then again it is comparing those results with that another agent, which is my external chaser data agent, right? Fetching information from external sources. Now, once they have this information available, the main agent is going to correlate and then come up with the decision. Okay, this is the external change that has happened, and based on this external change, this is my internal policy get impacted. Maybe the service SLAs or maybe the operating procedure has to be changed, right? Maybe the some particular section of your labor policy of has to be changed. Maybe the contract worker related to some there's some change in contract worker policies. All those changes can be then analyze in a much efficient manner. Why efficient? Now you don't have different manual owner, manual human to tackle all those situations, right? Now all these are coming to one places, and the agent is deciding based on that, and it can just derive some action out of it, right? So there's a continuous regulatory monitoring that happens between all these agents. So it's not like that these agents behave separately. So these are in sync with each other, so that if any response coming from each other can be always monitored and see the behavior of those response, correlate signal and risk, right? And generate actionable reports, right? So if there is any change in external policies, external compliance, my external agent will look into that compliance, and it will look in the, it will also look, the second agent will look into how that compliance is changing the internal policies. And if it is more risky, then it will raise an alert, okay, this has changed for that contract worker, this policy government has changed, and based on that policy on contract workers, our uh, internal policy has to be changed, right? So this can be detected, and then some actionable reports can be sent out, and it can be sent out to holders, right? And why it is important? Because suppose it is not happening, you are not changing, you are not complying with the external change with your internal policy, then at some point of time you have to be auditable, right? And then you will get penalized by, because you have not changed your policies, right? So that's where you can understand from this uh, explanation that we are using multiple agents, and why while using all this multiple engine, our complexity increasing, right? Because these has to be orchestrated, these has to be managed, they will make some decisions. So that's where multiple tools and agents are being utilized to solve one problem. Let's see one example how this looks like. As I have explained, right? So you have a first agent, which is your internal agent, which is internal knowledge agent. It is being talking to the policies or laws or reports which you have kept in your internal document. It is completely talking to internal documents of an organization. Now I can have one more agent, which is my external agent, which is listening to my external sources. It could be my news resource, it could be my financial new financial statistics in outside my organization, any other macro changes in the global scenarios, right? Now all these two agents are being connected with my orchestrator agent. This is my boss. So this agent is telling, okay, based on the query, from which agent I have to take information. If my query requires information from both the agent, it can take information from both the agent. But ultimately, it is the orchestrator who is going to decide what to take the decision of it, right? So that's where this complexity is increasing, because these three agents, they are using some tools, they are using memory, they are using some orchestration, and these are connected to each other. And that's where it looks simple, but in technically, when you are building all these things, it becomes complex, right? And based on the decision what orchestrator agent is making, we can send out to alerts to management. If there any change in policy, internal policy is required, definitely management has to take some action. So alerts can be sent out to them. If there is any change in external policies or external news or external scenarios or impact, then the process owner has to be updated accordingly. So this is how a high complexity agent typically looks like. It's just not that this is the only uh, schema or design of the high complexity. You can design differently also, but it's simplistic to start with 2 or 3 agents that you can understand the complexity of it.
Yeah. I think, Sumit, we are getting into the more technical aspect now. At this stage, maybe we can take a minute. Let's see if people have questions. We can take a break of maybe 5 minutes and then just come back to it. I think Anurag has a question. Yeah, Anurag.
Hey Vineet, I'm just having one very simple question, right? So this high complexity agent, what we are talking, it is kind of similar to agentic AI solution.
Yes. So
Okay.
think of agentic AI solution wherein multiple agents are synchronized with each other. The entire design is such where the task which are executing, they are being orchestrated by one, you can call that as a master agent, just for the sake of discussion, which orchestrate all the task, subtask, and make sure that it can operate autonomously. That's how, in simple definition, you can call agentic AI. Sumit, you would like to add to that?
Yeah, I think this is correct because this when you add one or more number of agent, it becomes an agentic process, right? So
Yeah.
that's one way of
Urmi,
correct.
yeah. Urmi, you have a question here.
Yeah, I just wanted to understand this low, medium, and high complexity agent, can it occur in one agent itself, like depending on the task that we give, or it is built only that way?
This
Sumit, I think more
depends
design.
upon, yes. This depends upon the problem, how you are solving problem. So I can use one agent with n number of tools. Okay.
I can use it
But
for low, medium, or high complexity issues.
yeah, so for
Is it?
low, see if you increase the number of tools, okay. So number
Hmm.
of tool increasing means you are giving more context, you are giving more circumstances to your, the reasoning is increasing, then it became slower, so right? And when it became
Okay,
slower, yeah, so that's where the complexity is getting increases, right? Because you are more reasoning,
okay.
you are performing more number of tasks, right?
So I think complexity, Urmi, has to be seen with respect to how much of decision making has to be done by the agent. If it is, say, purely rule based, what is rule based? There is some input. That input has to be computed using some calculator. Now it is a rule based thing. Input comes, output comes back, right? Using a tool like calculator. Now suppose you add some more computing to that particular computing calculator, and say that, look, if this particular answer from the calculator is going to be more than this, then go and do this. Right now you have another agent which is going to do certain thing based on the output of this calculator. That means now some next level of reasoning has come into it, right? So the this is more, should be seen more like a spectrum, where from the left low to the high, with respect to the reasoning of the agent, depending upon your task objective, will keep changing. And I think that's a very important consideration, because in today's time we have quite a lot of tool. One of the very popular one is from Microsoft Copilot, and I think Sumit will tell you more in detail about that. We should be knowing what is the capability of the Copilot, at what stage we would be encountering more complexity, and I really have to go for more code implementation, more API of LLM, which I have to use for more building up more capability into my agent. Up to certain extent, when it is more rule based, maybe a simple Copilot license is good enough. But moment I add one extra reasoning to it, then the complexity will call for some bit of code, from no code to some bit of code, and then it will keep growing up based on what kind of work you are going to do. Sumit is going to talk about all that, but shall we just take a break for 5 minutes, Sumit? What do you say? If you are okay,
Yep,
everybody is
yep.
okay. What do you guys suggest? You want to have a break, washroom break, or we can continue?
Yeah, washroom break. Yeah.
Okay, okay. So let's just come
Just a
back at
quick two,
8. Yeah,
yeah, just a
it is
quick
8 2.
2 to 3 minute break.
Yeah, that's fine. So 8:10 we will just come back. Yeah, Sumit, you can also have some water.
Okay.
I think we can get started, Sumit.
Yeah,
I
sure.
guess everyone is in. Yeah, we can get started.
Let's start and let's move to core components of AI agent. And I will be little covering it quickly so that we can directly go on to the code part of it and how this entire structure can be formed and can be uh, created so that we can look into this, right?
Sumit, you are mute, I guess.
Sorry, I was talking on mute. Sorry. Yeah. So let's talk about some important core part of that AI agent building, right? So first thing is that we need to have some memory, correct? So like we human, we tends to recall those conversations. We tends to suppose somebody has given me, my manager has given me some tasks, and it may be on some deadlines, and that could not be my priority. So I may recall that task later on. So that like we human tends to have that memory so that we can take action further later on. So like AI agent must also have some memory, right? So it could be short-term memory, it could be long-term memory. How it helps, what kind of improvisation memory can give it to you? Like it can give you the enabled personalization. What does it mean exactly, personalization? Suppose you are using that consumer platform of ChatGPT or Grok or any other platform, right? Suppose that platform doesn't have any memory in it, right? You are going to ask something and then it responded back to you. Now imagine the entire context of that first conversation is not there because there's no memory. Then you are again going to ask some question. Now it tends to forget because it doesn't have that memory to give you the previous prior context that which you have set up in. So that's where memory comes into picture, which gives you the personalization sort of things, and it also helps to improve consistency. How? Just like I mentioned, when you have that memory, you could retrieve the older conversation. You can always retrieve the previous context for the follow-up things, right? So this is more on the short-term memory. You can also have long-term memory. Suppose you, even if you are using ChatGPT, you have some query being asked 2 months back, but you see still in your user profile all those being saved. How they are using that? They may use some database to store your conversation or some kind of long-term memory which you can retrieve later on. So short-term memory generally means you are stick to that particular low level of memory, maybe in process for that particular duration of time. After some duration, that memory is no more available. But long-term memory, which you can later on also extract from the database, from different sort of other storage, right? You can always retrieve that information. So that's where memory come into picture, just like human. AI agent also have that memory.
Again, got mute, Sumit.
I'm not sure why it's getting mute, but and I can, okay. So next part is tools and functions. Just we talked about uh, some during this previous conversation, we talked about different tools. Why we need tools? We need tools to perform certain actions. Suppose I want to fetch uh, some relevant document from my store. I can build one tool. I can enable that tool with my agent, and that agent will extract that information. Similarly, like I have to extract from maybe some external data. Suppose I'm working on a travel management app and I want to get the travel itinerary from the different airlines, buses, trains. I need to get that data, right? To make sure that my agent can give me the required information. I'm asking, okay, can you please check whether on 3rd of February, do we have any flights available? How does it knows until and unless you don't have that external information coming to that LLM? That's where tools and functions come into picture. They are actually just the rule-based Python program or any other language program. It's just a program which has some certain fixed output out of it, and that output you are enabling with your agent, so that every time certain queries coming and which requires my agent to search for the travel airlines itinerary, so it can take that data and it can then solve, then give you the response, right? So that's where tool and function come into picture. Third one is retrieval and augmented generation, RAG, very commonly used, and it has certainly uh, given an edge to the enterprises to solve their problems, business problems, to make decisions, right? And how does this RAG framework works? It actually literally means retrieval augmented generation. So there is some retriever, and that retriever is basically trying to retrieve the. Am I on mute or again? So that retriever is basically trying to retrieve the relevant content, right? It could be your internal document which you want to retrieve so that your LLM can give you better accuracy. And it can also give you the up-to-date information, right? Why we need RAG? We need RAG because we are solving two problems. One problem is your data is out of date, and you don't. Second problem is you don't have any source to that data. For example, if I have to give you an anecdote, suppose one of my friend asked me, Sumit, can you please tell me which of the planet in our solar system has the highest number of moons? I can tell him, okay, I remember I have read this in my school days. It is like a Jupiter. Whatever comes up to my mind or head, I am just giving you that answer. But that answer, I don't have any source out of it, right? Now, I later on come to realize I went into the NASA and platform or website. I see, okay, no, it's not Jupiter. It is Saturn who has the highest number of moons in our solar system, right? Why? Why earlier it was wrong? Because your LM doesn't know that information, because generally those are being trained on the older data. Maybe that during the time of training, Jupiter has more number of moons and it could have trained on that, and it is giving you the wrong answer. So that's where you require RAG, where you can insert or you can update your document with the certain information out which is out of date. Now your your agent is now having the up to date information because you have given that information as a form of a document, right? And second thing, now since you have given that information, you know the source of that information. So that's where these two problems are being solved by RAG, right? Retrieval, augment, and generation. The fourth part of it is the UI element, right? So any application you are building, if you are using this building any agent, you must have some UI element of it, right? Without having UI, how you are going to send that query? And suppose I also want to see some insights, some visualization, some dashboard, right? So that's where I need some interface where I can get that all those responses. I can send my query, I can view my response back. For that reason, you required an interface, and it's not an intelligence. It's basically just that interface you can connect with your agents, so that all those tasks which agents are doing can be visible on the front of your screen, right? That's where user interface coming to picture. Any question in all these four core components you are not able to understand? I can again explain in much better way. Okay, if not, then yeah. So these are the four important elements or components of an agent. You must have a memory. If you are doing some task, if you want to act, then you have to enable some tools. And if you have some policy, internal documents, internal SOPs, or any kind of document which which you have, and you want your LLM to up to date, and you want that my LLM give me the response with the source, so you can build an RAG system where your agent will retrieve those information from the those documents. Now, the last part of is the hosting and runtime. This is all okay. You understood what is the agent, how agent can perform different tasks. Low, if you are having low complexity, it means the number of tasks is less. If you are having high complexity, there are more agents working in order to solve your query. All this is okay. You have created all this. You have that design. But certainly for me or any other person to use it, it must be hosted in some platform, right? You cannot just simply use a consumer platform, right? If you have some credentials, if you have some PII, right, personal sensitive information, and it is actually very very important aspect of it. In my use case, which I work with different clients, you cannot go without removing those PII information, all those sort of things, and you cannot deploy things, right? And if I'm going to use any consumer platform, I cannot put my document because that can contain sensitive information, right? If I have some SOPs or SLAs which are completely internal to my company, I cannot just go directly into consumer platform and I put my document and I certainly you will get sound results, but the problem is that you don't have the private network, right? So that's where hosting and runtime is important, right? And in hosting and runtime, what you do is you create a private network, you create a private agent, right? So that your internal document should not go out of your network area. It should remain within your firewall, right? So that's where you must have some models from different companies like ChatGPT, Claude, Anthropic. What they used to do, they used to provide you some sort of programming interface API, and those API you can build your agent, you can deploy your agent, you can deploy those agent on some particular cloud, right? Maybe Azure or AWS or some server, and you can enable those endpoints. You can call that model, right? All those sort of things are happening within a private network, right? Where it is very secure, so that you can always monitor the logs, traceabilities, observability, right? This can be trackable, and you if you have to sometimes scale it up, right? So you have in order to scale it up, you have to have some cloud services being uh, there which can help you to scale your solution, right? So that's where this entire picture come into picture, and it is very important to understand that private network, we cannot use any consumer platform. When we are talking about enterprise solutions, we have to use that private agentic model from different companies like ChatGPT or Azure OpenAI, and use those private agentic models, and then we develop within our cloud, and we host it with some deployment techniques. And then once you have hosted, you can create a URL. You can use that URL. You can share with URL with different user. They can run that app, right? So this is how you also have to host it, because if you are not hosting it, then you are the only one who's going to use at your PC. That's the whole thing. And when I talk about private network, it's very important to understand you cannot share the document with consumer platform. You have to make sure while also doing building for the enterprise that the accessibility to those models should not be with everyone. The PII information, the all those things are being autonomous, not autonomous. It should be removed from training or so. On if you have to solve any particular thing, then you have to take care of one thing, that you should not use all the documents just to solve one thing, right? So you have to make sure, for me to get the response, to me to get the goal done, I must share only relevant part of documents to my LLM model, right? So these are the key consideration while we do with the enterprise. We need to take care of all those aspects. We need to make sure the network is private. No one is accessing those networks. We need to make sure PII are removed. Even internally, we make sure that this access to these models should not be with everyone, because it can be misused. So all those aspects we take care while doing the hosting with enterprise, or even if you are doing with yourself, you have to take care of all those aspects. So for with this, I want to conclude this session. But if you this theoretical or maybe implementation on the side of deck, we are almost finished. If any question so far previous to this, I can happy to answer and take a. So far, any question, or shall we go ahead with the
Yeah, I think we can go into the design and code. Good.
one second. Okay, so I have created one demo UI also and the part of agent, which I'm going to show in the code also. So this is a use case basically, which is a kind of regulatory and compliance intelligence. This is certainly highly complex agent, which we have talked about. Why? Because here we are going to show you that we are using multiple agents, just like we have shown in that slide where you have an agent for knowledge, you have an agent for external data, and then you have an orchestrator which decide uh, based on the information from other two agents, right? So I will be showing this how does it works later on. First, let me first go into the design part of it in the code, right? So that will be help to better understand how it is formed and then how it is working. Correct. Now, if I have to go to design, now what I'm trying to solve here is uh, two things, right? One thing is I have some internal operation policies, right? I have some SOPs, standard operating procedures. I have some SLA, service agreements. I have some also kind of capacity.
Sumit design is not on the screen.
Okay, okay, okay. Yeah.
No, I think it was in another tab. Just check that. All tab.
No,
Just
I don't think it is there in that slide. I think this is more or less same thing. It's more
okay.
complicated. So what I am going to show you is an orchestrator agent having two more agent as a subordinate. What orchestrator is going to do? Orchestrator is going to decide based on the query from the user what information I need to solve that query. So it may require some documents, uh, operating procedure which I have kept in, which is being tackled by agent one. And then second agent, I have been talking with the external API, right? So first agent, I will be showing the RAG pipeline, just like just now I covered this, why we need RAG, right? Because we have some internal documents where we want to my LLM to work with and that respond the query based on that particular document. My second agent is going to have some external API where coming some news feed is coming. So that is where I'm integrating my news feed to my external agent so that I know what is happening outside my organization. Once I have all these things, I have an orchestrated agent which will decide which tool to run, which agent to run. And based on the information from different agent, it is going to decide uh, and create an output format so that we know whether what kind of changes we need to take an action on it, right? So this is the same design I'm going to show you. Agent one with RAG for the purpose of solving the query from the documents. Agent two is having a tool which is taking the data from my news agency. Right. Let's go back to that code of it. So first I need to import some, and as to start with, I want to mention that for this entire demo, I am using two core framework. One is LangChain and the same family of LangChain, we are using LangGraph, right? Now, first of all, we need to import all those libraries, right? Uh, Libraries like Chat OpenAI and OpenAI embeddings. So why we need these packages? Because we are using LangChain, and LangChain is a kind of, it gives you a tool, certain kind of tools, so that a kind of template, so that you don't have to create anything from scratch. You can utilize those functionalities, those tools from those libraries, and you can build that agent on the template that what they have given, right? So first thing I need to have a UI. For UI, I'm using Streamlit. Streamlit is a popular Python library to create a data science user interface. Second, I need to have an OpenAI model, and also I need to call embedding. So I'm calling embeddings and OpenAI from LangChain. Now, third thing is document loaders. So this, why this we needed? We needed it for the RAG, right? RAG, in RAG, retrieval augment generation, we need to upload our document. That document will uh, be chunked into different parts. Once that chunk of the documents happen, it has to be embedded. So embedding means you actually do conversation of text into some numbers or some vectors, so that your program understand maths. It doesn't understand exactly the text like we do as a human. So that's where we are using a document loader, so that we can we can upload the document. We are using recursive character splitter, which actually split that entire document into different chunks. Then we are using fast vector store. Vector store generally stores those uh, chunked document in the form of vector, right? So that's where we need to have some vector store. Now, I'm for agent communication, I'm using some messages like system message, AI message, human message, and base message. System message is generally the prompt which you give to the agent. AI message is what your agent is responding, and human message is the query part of it, right? What query human is sending. And similarly, you for some tools like if I want to create, so this I want to create a tool to fetch. I want to create a program. So tool, just understand it as a program. I want to create a program, just a simple program which can fetch the news information from some particular resource, right? So in order to use that tool, you have to import that tool from LangChain so that you can utilize that particular program with your agent. Then for LangGraph, you have to create a state of machine, so that when you are making that agent, right, you are using multiple agent, then entire tracking and entire workflow can be utilized with the same state, right? So that's where state graphs comes into picture, where you can just graph your each agent, their working, their how they are responding to each other, whether they're not continuously talking to each other. So entire workflow you have to make it into a graph, so that you do not divert from your original intent and path. And then you have memory, so that each agent shares the same memory, right? So why we need memory here? The simple problem is because I'm using multiple agents. Now, suppose my query is coming to my first agent, how my first agent will work with another two agent? It has to have share the memory to other two agent also, right? So that each agent can know the context of it. So that's where memory come into the picture, so that each agent are having same kind of context, same kind of memory during the entire conversation which you are taking place. There are some other libraries, general libraries like Pandas, Scikit-learn to Pandas for handling the data, Scikit-learn for handling the machine learning model. I am using one machine learning model to do a forecast, and some other common libraries which is not generally important to talk about, but yeah, you can always learn it, right? Now, how I'm going to design this one? As I talked about, I need three agents. One, my knowledge agent. Knowledge agent has to communicate with the document, right? So which means my knowledge agent must have one tool which can perform the task of reading that content of the documents, right? So what I come to know, okay, let me create one tool and let me enable that tool with my knowledge agent, correct? So this part where I have to provide the API key, that is what I just talked about, right? Private models, right? So I cannot upload these documents in real time in the normal platform like ChatGPT or Consumer or any Grok. But how I can solve this? I can take that private API keys from any of the provider, and I can use it in my program. Right. So this is where I have to. I'm checking in this part of program whether my API key is available to me or not. As of now, I'm not showing that API key in my code because that's not a standard practice. You have to keep it invisible. Next time is I need an LLM. So in this line, you can see I am creating an LLM ChatGPT OpenAI, which I just called as a library from LangChain Chat OpenAI. So I'm creating this an object of LLM as an object so that it can use that model, right? And I'm storing into a variable called LLM. And this LLM I'm going to use, this is a common for all three agents. So I'm not changing model for each. If you want, okay, I want my knowledge agent is very working very less. It is not as the highly uh, engaged agent. So I can reduce my model. I can give a little lighter model to it. But here I'm using the same model for all three LLM. So that's why I just kept it as a single so that one place I can define this model and I can utilize the same model in all agents. Now this is my folder where I kept my.
I cannot see the screen.
You're not able to see my screen?
So I can see.
Okay, I'm just getting one
What is it?
SV letter there. I just don't know. Maybe some problem with my thing. I don't know. Sorry about this. I mean, I can only see S and V2 initials on the screen.
Okay, I'm not sure. I'm sharing my screen if any other is facing same or just with you.
No,
No,
I
I
can
can
see
also see.
completely. I can see the code.
Yeah, yeah, I'm
Okay.
explaining the code part of it.
Yeah, I'll just log out and log in again. Maybe I'll check
Yeah.
that.
Yep, yep. Yeah. Now I have to keep my folder. I have to create one folder and I have to keep my document which I want to use inside that folder. And this is my folder compliance docs. And within that folder I have the knowledge source, the document which I was talking about, which I will be using reading with the help of RAG application. Now, this document, you can see I have kept some the dummy operating procedure, SOPs, SLAs, some capacity planning rules, quality and guidelines. So these kind of either I can use one document or you can use a number of documents depending upon your use case, right? If you have multiple documents, you can always put multiple documents separately, right? Now my task is to read this because I want to query on this data only. I don't want to give you a generic response without just out of internet of any other sort of training, right? So that's where first I need to create a tool, right? To search the document, right? So that's where I'm creating this tool called RAG tool. So I'm giving it as a decorator here tool so that I can define this function as a tool. So this is a function where I'm just creating a tool. You can see RAG tool. This is for only compliance policy. What it does, it calls the retriever. Then I have to create a retriever. How I can, why retriever? Because the retriever help you to give the relevant information. In order to build that retriever, I have to upload the document. So this is C directory loader, like loader is equal to directory load. So what it will do, it will read all those text file. As of now, I just kept the text file. You can change the file format. If you have PDF, Word document, you can kept it. So this will read whatever files are available to my folder. If it is not available, it shows none. Now, after it knows, okay, these are the files that I have uploaded. Now I have to, suppose I have a book of 200 pages, right? I cannot feed that entire book of 200 pages as a prompt, right? Even if you try on the consumer platform, it will throw you an error because of the one reason, which is called what we call as a context window. Nowadays, if you see, most of the models are having context window of 1,28,000 tokens, which means it can only in one query, it can only take that much of the text content. So there is a limitation of text content which you can put inside that your work with your LLM. So how we are going to solve that problem? So people, and it's just not me that have solved this. Already being used in different places where they are chunking, they are chunking that entire book or entire document into different chunks, and those chunks are being embedded then, right? So that's where I am calling here vector store. Why? Now my text is there. I have chunked that text. Now that chunk text, each chunk text has to be created as a vector. That is what we call as embeddings. So embeddings which allow your text to convert into vector and numerical form. And once it converted into a numerical form, you can store into a database, which we call as a vector database. So it only store that vector form of information of that chunk which we have created, right? So that's where the entire retriever will work. Once the information is stored in the vector database, you can always store, retrieve that information. How you are going to retrieve? You just put in query. Query will check whether that it will check for that document, and it will, from that vector database, it will find out the similar kind of uh, information or chunk from which that query can be answered, right? And how this vector store work, that is entire thing which we could have covered more, but I don't want to go into the technicality of this semantic. There is something called semantic search, right? That happens with the vector database. So your query is also a vector. Now just assume your query is being converted into a vector, a numerical form. That numerical form is going into that vector phase. It is trying to match the similarity. Once it finds, okay, this vector are very close to this vector, it will fetch that response. This is how retriever works with the vector database. Now you understood, like I have created one tool, RAG tool. My RAG tool is using a retriever to retrieve the information. How retrievers works, it splits the document, chunk it, and then embed into vector database. So this is done. The tool is being created. Now I have to enable this tool with my agent, correct? So that we will do. So before that, I also have another, I have shown in that diagram, correct? So for agent one, we have built this part of it, RAG policies. This is now I also have to build this program where I can extract, or I can fetch the data from news, particular news source on API, which I will be enabling it with two second agent, which I will show you later. Okay, let's go to that second part of it, external tool agent, second tool. So as of now, I'm just creating tool. I have not created any agent. I'm just creating my tools, because without this tool, anyway, if you use agent, if these tools are not available, you won't get that information, right? If I'm not having this RAG tool, no matter what I write in the query, it won't give you the response from that document. So if I don't have this tool, no matter what I write, it won't fetch the news, right? It will hallucinate. It will give you anything, any kind of news without any source. Now, in this second tool, for my second agent, I'm creating this tool. What I'm doing is I'm using an API from news data IO. You can also, this is a public API. You can always create an API. It will give you the news, different sort of news. So I'm calling this URL. I'm requesting to give me the news. I'm passing my API key here, and I will get the result of the all those news search results within by using this function program, right? And this is the program. It will always return the same. Always remember, tool is a particular task. Task means task has a certain outcome. The outcome never changes for a task, right? So same way the tools, it's a rule-based program which gives you a certain results. Now I have this tool created. Also, I want to do some forecasting. So I have created one forecasting tool, right? I want to forecast based on some data. I want to forecast whether based on the previous month experiences, whether my uh, changing the policies, internal or external, is there any risk associated with it? So that's where I'm using a machine learning model, the model called as a linear regression model, is predict a number out of it. So anything which is greater than 60, I'm saying, okay, this is high risk. Anything which is between 60 to medium, I'm saying it is as a medium risk. Anything which is between below 35 value, which I'm saying it is a low risk, right? So this is where I'm defining my one more tool. This is for the forecasting, and this tool I'm making it for my orchestrator agent. I'm not using this tool for agent 1 and agent 2. I'm using this tool with, I'm going to use this tool with orchestrator agent, right? So that if any time my user is asking, can you just forecast the risk associated based on the data which I have provided? So what it will do, it won't run this agent 1, it won't run this agent 1 because I have enabled this orchestrator agent itself with that tool. So that tool will be triggered as soon as any forecast related query is coming to my main agent, which is my orchestrator agent. And it will just give you the response directly without using any one of the agent because this is not required for him. It can solve that problem by its own. That's where you may think of different sort of techniques, how you want your agent to perform. I could have also created one agent for the forecasting. I could have done it, right? I could create an agent 3 and agent 3 task was only to do the ML forecasting, right? But you have to also think how fast I want my response, how accurate I want, and based on that entire problem which you are solving, you have to configure your agents, right? I can also use just one agent orchestrator. I can use all three tools, RAG, API, more for this 10, for this one agent, right? One agent with three tools. So this kind of design we have to work with depending upon the problem we are solving. If we are using different domains of the things, then definitely go ahead with the different agents because each agent will then tackle the domain of it, right? Expertise of it. Now coming back to that code again, the design again. So all the tools are being now created, right? But still we don't have any agent so far to use those tools. And also we haven't enabled any kind of memory, right? We have talked about that the core element, one is your memory, second is your tool, and UI element definitely we are going to see. So memory, this is the part where I am creating a agent state. Why I am creating this agent state, and in this agent state I have internal, inside, this kind of variables, external signals, need internal. So this is why I'm creating, because I want to share the common state between my all three agents, right? I don't want that I am somebody is asking a query on that my agent, and my orchestrator agent only knows the previous history or the state which is working with that particular query. And if it is not passing that state to knowledge agent or the third agent, the external signal agent, then what's the point of using that? Because the other two agent must also have to understood, right, what it needs to be done. So that's where I'm passing a memory state, agent state, so that each agent must have that context of the query which is being given to the orchestrator. Okay, so I have now agent state, which basically gives you gives all the agent the same state of conversation, same state of work. Now I have to create those agents now. Since I'm using LangGraph framework, in LangGraph framework, everything, every agent is considered as a node. So as I talked about, I have a one orchestrator node or orchestrator agent, and other two agent, knowledge agent and external agent, those are my worker agents. Those are my worker nodes, right? So this is a part where I'm creating a knowledge agent. Now I am creating this one. I have created as of now RAG. Now I am creating an agent, and I am going to enable that RAG tool which I have created for that agent, so that my agent one will work with that RAG tool, so that entire document information can be considered. In this, I am giving some system message, system prompt, which is basically the prompt for that particular agent, the instruction, how that agent has to behave. You are a knowledge agent, use RAG tool. Then I have I'm giving this I'm creating this agent, right? Create agent, and I'm passing this LLM the same I've created earlier. I'm telling this agent to only use React tool, right? You can see I have given only one tool, which is React. So here I'm telling, okay, this agent must use only React tool, and it should not take any other tool into the consideration. And once I have that React tool enabled for it, this is the response part where it will, once this agent is being triggered, it will give you the response by invoking that agent. And you can always return some kind of output out of it. Now I have to design my second agent, which is my external agent. Same way, I am giving the same thing to the external agent, nothing change. I'm just changing my system prompt because I now it wants to work only with the news update or only with the external signals. And what tool I'm giving it to, I'm giving it external tool. And similarly, I'm getting the response out of it. So my two agents are done. Now, again, still I am left with my main agent, which is my orchestrator agent. Right. So this is the prompt for my struck orchestrator agent, and this prompt and below that prompt you can see orchestrator node. So this is where I'm defining my third agent, main agent. This is the main agent which is going to utilize other two agents. And with this agent and what prompt I'm giving, you are an orchestrator agent, ensure all parts of the user's question are answered. If there is any external information is required, use external tool. If there is any internal SOP based information is required, use a knowledge agent. So you can always structure the prompt how you want your entire workflow to orchestrated, right? Different agents being orchestrated with the help of main agent. And you can see in orchestrator, I'm passing the state as a agent state. So in every agent, I'm passing the agent state, which I just talked about, that common memory across each agent. So that's ensure that the state which is being given to orchestrator, the same state being passed on to worker agents also. Now in orchestrator agent, I was talking about that I have enabled one forecasting tool. So I just kept a very small data, which is like time and risk score. So time is basically the month, first month, second month, third month. And for those month, I have some risk score 55. For second month, I have 40. For first month, I have 30. So what is some query is coming, okay, what will be the next month risk appetite? Then what it will do, it will run that ML model, which is being enabled to my orchestrator. It will give you the prediction out of it. Now this is the last. Yeah.
Sorry, where is that ML model which you just referred?
Yes. So I have created one tool. This is the tool forecast risk. Okay.
Oh, okay. Okay.
Okay. So this is using linear regression to predict the number. And once the prediction, it will give you the response. So like that, you can create n number. I'm just giving you an intuition how the tools being created. Each tools are doing the task, particular tasks. So, and these tasks are being associated with the LLM. And then when you enable those tools, that's where we called as an agent to perform particular tasks. Last part, if now I have created everything. I have created my agent one and the tools for one, agent two tools, orchestra, and all those things. Now I have to make a workflow so that the entire process will work as expected. Because there should be some starting point, right? How I can make sure my query is going to orchestrator agent only. So that's where I have to define the workflow. To start with workflow, I have, and this is the LangGraph framework, uh, just to create a workflow. I'm First, I'm defining a workflow, which is the state of machine, so that my each agent have that state of machine. Then second part is to define the node, because I just told that each agent in LangGraph is being treated as a node. So I have to first define the node, my knowledge agent, my external agent, my orchestrator agent. So far, still we have not yet running that and anything, any part of it. This is the first point, 252, where I'm setting the entry point, right? I'm telling my workflow the entry point is orchestrator. So every query must come to this entry point. Now entry point, that's where our flow is started. Once that entry point is started, I have to tell on certain condition whether that orchestrator has to decide whether to call the knowledge agent, whether to call the external agent, or whether to call both of them. So that's where you have to give the conditional edge, when to call which one. So this is the logic. Then you try to tell what to use when. Yes, and this is the last part where workflow add age, external and internal. So add age means once you have called this agent, the agent will give you some response back to the orchestra, right? And this is where the response back to the orchestra is going. Knowledge agent to orchestrator, external is also response from external will also go to the orchestrator. And the last part of it, the graph, where I will be compiling with the memory so that each state is maintained within the workflow. The state across different agents are same, and I don't have uh, any inaccuracy due to not having proper state of memory to each one agent. So this is the end of this entire setup, this entire workflow. This is where we have built it, this entire high complexity agent. And this is the below part. I won't be covering much of it. This is more on the Streamlit UI part of it, just to give some title, caption, the headers, right? I also have that upload option here. So I just created that part of it to upload the files, right? And the text area query part of it, items where you can give some query. And as soon as I click on analyze button, the entire process should be start running. So that's where this condition is coming, where as soon as person is clicking on start, that workflow will start, keep on happening. And important part here also, this last part, which is graph.stream. So you may have seen your chat GPTs, right? Where when you type some query, it start to giving you the quick response, writing down, even though the response is not completed, it keep on writing in the live state, right? So that's where we call it a stream. So what it will do, so when my query is coming to my orchestrator and suppose my orchestrator is telling, okay, both agent has to be worked and fetch the information and provide to me. So streaming will help you to give the live response from each agent and in the UI so that you can view what those agents are doing, what kind of response they are generating, and you can view that option so that this is part where you can have that live stream also being. We'll look into that last part of that solution in the UI. Yeah. And this is it, the session management, because I wanted this follow up, this memory part to work with the entire session. And if you want to long-term memory, you can use some kind of database, just like vector database for documents. You could also use some other relational database. For now, I just kept a session-based memory so that if I'm running tool now, if I'm using my tool now, until the time I'm using that tool, it should not forget what has been talked about. But as soon as I restart my app, it will start to reset, and then context is lost then. The memory is lost then. So you can work on different type of memory in order to make sure how you want it to perform, right? So this is it of the entire design part of it. Any question in this design so that I can just last part, maybe I don't know how much time I have to show you how this is working. Let's go back to and just run one or two query. Suppose I just want to have first query on my internal document. I can just write, okay, what is the internal SOP say about my capacity planning? Now you can see multi-agent analysis is working and it will try to call knowledge agent. Yeah. So you see it's called that knowledge agent and it reads and provided, okay, the standard production capacity is 10,000 units, surge capacity is this. And then it passed that final report. Final report is being created by my orchestrator agent, right? Similarly, I can use other queries also just to make sure that things. how do recent regulatory changes in our internal policy? So this should enable both agent working together, because I'm asking about my internal policy, how it is impacting with the help with the change in external policy. Let's see. You see, first it tried to calls the external agents, which it says, okay, there are something or something not available. So based on, so you can tune, because this is just a very rough. I've not created as an exact and accurate method information. And then it ran knowledge agent to check, and then orchestrator is telling based on the recent regulatory changes may impact our internal policies in several key areas: documentation and compliance, risk management. And the final report, it has created, orchestra has created the entire final report based on both the information provided by both the agent. So this is how you can build, this is how you can design, and there are some consideration which I just talked about. Yeah. Any question here? This is it from my side, and I don't have
Yeah.
anything.
Yeah, I think a lot of stuff covered by you, Sumit. I guess we can open the floor for any question right now. Of course, more can come. Thank you, Anurag, for your acknowledgement. Any other question? Any thought so far? I mean, I know it's a vast subject. You might have got one intuition how, after all, such a cutting edge thing is working. People are talking. What exactly the beast is? At least you have got that intuition, I hope. But still, you can have a lot more question and direction for future learning. So I think one of the key thing by the time question come, let me share from the designer perspective. One of the key thing which you might have by this time realized that how important is to identify the right workflow. Because if my workflow is not appropriately figured out and I have not really divided the work breakdown in the manner in which I would like my process to run, there is a very likelihood that I will not be able to get things going. I mean, implementation, writing code about all this stuff is one part, which is certainly having his own semantics and have his own flow. And it's something which people can learn and do it. But the real dynamic part is all about what is your workflow, how you are going to synchronize all your subtasks, right? I guess you might have got some idea about that as one of the significant, most significant aspect of agentic design. Any question? Else we can conclude the session at least for now. All right. I think thank you very much, and please write down any question on the group in the email, and we'll be happy to answer. Okay.
Thank you.
Thank you.
Thank you very
Yeah.
much.
Thank you. Bye for now.